This online lecture shows you how to test for normality. I am going to do a step-by-step tutorial in SPSS that will show you how to complete the process. By the time you're done, you'll know how to identify outliers and deal with them, understand how small sample sizes can affect the honesty of an analysis, create histograms and box plots to spot normality, explore the distribution of variables using the frequencies command. You'll run the Kolmogorov-Smirnov test, and then you'll know how to use the split file command to check the normality assumption within each group of a variable separately. And to do so, we are going to recall that a biologist was worried about the potential health effects of music festivals. So one year she went to the Glastonbury Music Festival and measured the hygiene of 810 concertgoers over the 3 days of the festival. I'm going to expand on what Andy Fields provides in your textbook and report the results for day 1 of the music festival concert by showing you how to do all the self-tests and interpreting the results for days 1, 2, and 3. So what you're going to know is how to deal with the central limit theorem and when this applies to in a situation. You'll know how to do the PP plots or the QQ plots, the histograms, the box plots. You'll know how to measure the skewness and kurtosis when we run the different QQ plots and the PP plots. And then you'll understand how to use the Kolmogorov-Smirnov test and interpret it. So the first thing we're going to do is learn how to spot the outliers, and you can follow along in section 5.3.1, and I'll show you how to go about doing this with the plot histogram of a hygiene score for day 1 of the festival. So I'm going to go to Graphs, Chart Builder. I always reset it to make sure, since it shows the last chart you've created. Click on Histogram, drag the simple histogram to the chart preview. Click on Hygiene for day 1, drag that into the x-axis. Then I'll click OK. In the output, what you'll see is your histogram, and you will see right here that we have one outlier that is scored around 20, and we know that the scores ranged only from 0 to 4. So we need to identify the case that has the value of 20, because that is different than the other values. And we're going to identify that case by creating a box plot. So to do so, we are going to go back to Graphs, Chart Builder. I will reset it and then click on Box Plot. Click on the simple box plot and drag it into the form here for Chart Preview. I'll click on Hygiene, Day 1. This one will only let you drag into the y-axis here. And then what you're going to want to do is click on Options, and you're going to want to exclude variable by variable to maximize the use of the data. That way it will show you the specific case that is that has that value of 20. Click OK, click OK. Then in your output, you're going to see this box plot, and we will see that right now it is case 211, or no, so sorry, 611. And so what we're going to have to do is come back to our SPSS data set, and we can go to a very specific case. So what we're going to do is just type 611 in and say go. And we will notice that here on day 1, case 11 is 20.02. And so we're going to just assume that this data score should be 2.02 because we've checked the raw data, and that's what we're going to replace it with. So we're just going to type 2.02, and then I'm going to hit save. And what you'll want to do now is actually rerun the histogram and the box plot for the days of the festival, just so that you know that there isn't going to be another outlier and that everything was corrected and looks like you have normal distribution. And so I'm going to go back to Graphs, Chart Builder, reset it, go to Histogram, bring in my simple histogram, go to Hygiene, day 1, bring that into the x-axis. We'll click OK. I'll see now I don't have any outliers. All my data is in that range of 0 to 4, which is consistent for how the researcher measured the level of stinkiness or smelliness. And then what I'm going to do is go Graphs, Chart Builder, reset, box plot, drag the box plot into the chart preview, then take Hygiene day 1, come to Options, make sure I still exclude variable by variable, click OK, click OK, then I'll have it appear here, and I see that case 574 appears, but really it is so close. It's like a mild outlier, and it doesn't really show that that case is going to be out of the ordinary because it is so close to the upper whisker, so we do not need to worry about it. It doesn't break the assumption of normality. Now what we want to do is produce the other box plots for day 2 and for day 3's hygiene scores. So I am going to come here and then just come to Graphs, Chart Builder, we'll create it for day 2, click OK, click OK, then I have my chart for day 2, and then I'm going to go back and do Graphs, Chart Builder, and click on Hygiene for day 3, click on 3, click OK. Okay. So so now what I've done is just make sure that I look to see if any other variables have missing data and that I don't see any other problems with this data set. What I just want to do is make sure we don't have any cases that are excluding, and this is again so close to the upper whisker, we're not going to really worry about it. I'm going to do the same here, looking at those, seeing that they're close within the 0 to 4. I'm not too worried about them being considered outliers, and so I'm going to just know that we have distribution that's looking pretty normal based on those box plots. What I do want to do is also make sure I go back and plot my histograms for the hygiene scores for days 2 and day 3 of the festival. So I'll go back to Graphs, Chart Builder. I'm going to just reset this, go back to histogram, bring up the simple chart, bring up hygiene, day 2. Okay. See the data appears right here. Then I'm going to go Graphs, Chart Builder, day 3, drag that in, click OK. So I'm going to take a look at this data. And if you look at it, the hygiene scores and the distribution for days 2 and 3 are not nearly as symmetrical. In fact, they both look positively skewed. And in general, what this seems to suggest is that by day 2 and day 3, the hygiene scores were much more clustered around a lower end of the scale. And remember that that lower end of the scale or score means the less hygienic the person is. So this just suggests that generally people became smellier as the festival progressed. And the skew occurs because of a substantial minority that may have insisted on upholding their levels of hygiene here over the course of the festival, and the skewed distributions could be a problem if you want to use any parametric tests. So the next thing I want to do is plot the p-plot for days 1, 2, and 3 of the festival. And so we're going to look at the probability plot, or the PP plot. And it's just another way to check for normality. And you can follow along with this particular test in sections 5.3.2.1 using graphs to spot normality. And to get the PP plot, you have to use Analyze Descriptive Statistics p-plots. So we're going to first come here, go Analyze Descriptive Statistics p-plots. And this opens up a dialog box. And we are going to select all 3 of our hygiene variables. And you can do so while you hold the Shift key down and click on all 3. And then those are in your variable list, and you're going to click this arrow and have the arrow bring them over to the variable box, and that is transform to that area. And then we're going to just click OK to draw the PP plot. The data will appear in your output. Okay. So the data for day 1 scores fall really close to a near perfect diagonal line. And we all notice if we scroll down that as we go to day 3 and day 2, and then now, day 2 here, now day 3, you're going to start seeing that the scores fall very far away from the diagonal lines, and that those hygiene scores are much more clustered around the lower end of the scale. And you just want to remember that the lower the score, the less hygienic the person is. So this just suggests generally that people became smellier as the festival progressed. You can kind of see day 1, day 2, and day 3. So the next step we want to do is actually use descriptive statistics to look at normality. And so you can follow along with me by going to section 5.3.2.2, and I'll walk you through how to explore the distribution of the variables further by using the frequencies command, which is just accessed using the file path Analyze Descriptive Statistics Frequencies. So we're going to go to Analyze Descriptive Statistics Frequencies. And then the variables in the data editor should be listed on the left-hand side here. And what we're going to do is highlight all 3 of our variables. You can do so by holding the Shift key and then clicking on each variable. And we're going to click on this arrow and bring them over to the variables box. And then whatever analyses we choose will be done on every variable listed in the variables box. So if there is a variable listed in the variables box is selected using that mouse, it could be transferred back to the variable list just by clicking on it or clicking on the arrow button, and which should now be pointing to the opposite direction toward the left. So if you do make a mistake, it's really easy to fix it. By default, SPSS produces a frequency distribution of all the scores in a table form. However, there are 2 other dialog boxes that can be selected that provide other options. And the statistics dialog box is accessed just by clicking on the statistics button, and then the charts button is also selected here, where you can pick bar charts, pie charts, or histogram charts. And then the statistics dialog box allows you to select several different options of ways in which a distribution of scores can be described. And so what we want to do is click on this box, and for central tendency, we are going to measure the mean, median, and mode. Then we want to select standard deviation, variance, range, and then the quartiles, minimum, maximum, standard error of the mean. And then for distribution, we want to pick skewness and kurtosis. And so that just helps us to check the distribution of the scores to be normal. Now what we're going to do is click continue. The charts option provides just a simple way to plot the frequency distribution of scores as a chart or a pie chart or a histogram. And since we've always plotted the histograms of our data, we don't need to select these options, but you could use these options in future analyses rather than doing all the processes separate. And then when you have selected the appropriate statistics options, you can just go ahead and click OK. So what will happen in the output menu is you'll see a table with all the statistics appearing, and we have the mean, the standard of the mean, median, the mode. We have our standard deviation, the variances, our skewness, our kurtosis, the range, the minimum, maximum, and you understand what many of those mean, but there are something I want you to look at. I want you to notice that for both the skewness and the kurtosis scores, a perfectly normal distribution should return a score of 0. And otherwise, a positive skewness value indicates a positive or right skew, and a negative value indicates a negative or left skew. And the higher the absolute value, the greater the skew. So similarly, a positive kurtosis value indicates positive kurtosis, a negative one indicates negative kurtosis. And the higher the absolute value, the greater the kurtosis. So SPSS reports a statistic called standard error of kurtosis and then the standard error of skewness. So kurtosis and skewness. And this allows a simple rule of thumb to be applied. If you divide either of those scores by its standard error and the result is greater than positive or negative 1.96, it suggests that your data are not normal with respect to that statistic. However, we need to remember that the sample size is large, specifically 810, and so it's not surprising to find that the scores for skewness and kurtosis to indicate significant problem. We just want to apply the central limit theorem in this situation. Now I want to be able to show you how to do the Kolmogorov-Smirnov test. And so you can also use the Kolmogorov-Smirnov and the Shapiro-Wilk test to test the assumptions that your sample data are drawn from a normally distributed population. But both require interval data and they can be run in SPSS. So both test the null hypothesis that the data comes from a normally distributed population. The alternate hypothesis is therefore that the data comes from a population that is not normally distributed. Consequently, if the results of either test are significant, meaning p is less than 0.05, rejecting the null hypothesis means rejecting the assumption of normality for the entire distribution. So a typical use of the Kolmogorov-Smirnov and the Shapiro-Wilk test is to check assumptions of normality required by other statistical tests to be used later in your analysis and in the chapters. Both tests are very sensitive to the size of the sample. With a large sample, even small deviations from normality will be reported as significant, and as a result, both tests should always be used in conjunction with visual inspection of the histograms and skewness and kurtosis measures. So Andy Fields offers the following advice when you're reviewing statistical tests of normality. Always plot your data as well and try to make an informed decision about the extent of non-normality based on converging evidence. In other words, do not be over-reliant on tests such as Kolmogorov, Smirnov, and Shapiro-Wilk. If, however, the assumption of normality has been rejected, subsequent significance testing should be done using methods that do not require normality, such as the non-parametric tests. And an alternative strategy is to manipulate your data set to make its distribution more normal. So now I'm going to demonstrate how to run the Kolmogorov-Smirnov test using the following procedure. You need to select Analyze, Descriptive Statistics, Explore. Then when the dialog box opens, you need to send your variables that are to be tested into the dependent list box. So I'm going to select hygiene day 1, 2, and 3 and bring them over to the descriptive list. Now what I'm going to do is look at statistics, and I'm just going to see that the descriptive box is checked and click continue. For plots, I'm going to click on this and see that it's just factor levels together for the box plots, and the descriptives will be stem and leaf, but I do have to check the normality plots with tests. Please make sure that is selected, then click continue. Under options, you need to be able to select the cases pairwise. If you do it listwise, you eliminate so many of the cases that might have just 1 or 2 data collections that you'll really lose the ability to look at your data set entirely. So click continue, and then I want to hit OK. Alright, the thing you want to focus on right now is going to be the tests of normality. So you just have to scroll down a little bit, and then you're going to focus on this specific test right here. You want to focus on the table of the KS test. For each variable, the table shows the test statistic, the degrees of freedom, which is your sample size, and the significance value for the test. The KS test shows a non-significant value of 0.096 for day 1. The KS test statistic is significant for day 2 and day 3, which is illustrated by the skew we saw in the histograms. Now I'll show you how to do the normality within groups and the split file command. You can follow along in section 5.3.2.4. When analyzing data, it is sometimes useful to temporarily group or split your data in order to compare results across different subsets. And this can be really useful when you want to compare frequency distributions or the descriptive statistics to look at the test for normality with respect to categories of some variable like gender. And I will show you how to use the split file function. So in SPSS, you go to Data, Split File. And then what you'll do is click on Organize Output by Groups, and your box will now open, and you can select Gender and click the arrow key and add gender to the box for groups based on. Then what you want to know is that the splitting variable should be nominal or ordinal. SPS will not stop you from using a continuous variable, a scale variable, as a splitting variable, but it is a bad idea to try to attempt this. SPSS will see each unique number value as a distinct category. You can click OK, and then to show you how this works, I'll go to Analyze Descriptive Statistics Frequencies, and then click on Statistics, and use all the same frequency statistics I demoed earlier. Click OK, and then what you're going to see is that you'll have statistics for the males, and you'll have statistics then for the females. And this is just one way to compare to different groups. But I do want to now show you how to run the KS test and showing how to perform them for the males and females separately. So what I have to do is actually switch the split file off. So I go to Data, Split File, and I'm just going to reset it and click OK. Now I'm going to go to Analyze, Descriptive Statistics, Explore. I'll put my hygiene variables in the dependent list. I'll put gender as the factor list. I'll keep my statistics the same with the descriptives. I'll keep my plots as the stem and leaf and the factors level together. Please make sure you have the normality plots or tests checked. Click OK. For options, we want to make sure we exclude cases pairwise. Click OK. Click OK. And then in the output, we are going to get our data so that when we scroll down and we see the tested normality, it now shows us the output for males and females by each variable. And so the self-test asked us to compute and interpret the KS test and the QQ plots for males and females. I did it for day 1, 2, and 3. So what I want you to just notice is as you scroll through the data, our QQ plot for day 1 is, following the diagonal pretty well. I would say that none of the scores are really skewing away from or significantly below the diagonal line. But that as we look at day 2, and then we'll see that it kind of shows observed values that were pretty similar for males and females. They fall a little bit below the diagonal line, so that could indicate a problem with kurtosis. It's starting to form a bit of an S shape, which indicates skewness. And this information really is not surprising since we saw significant values in the KS test. And then on day 3, we notice the plots are not very different from day 2. They do fall maybe a little bit closer to that line, but they still have sagging below the diagonal line that would indicate a bit of a kurtosis, and then the skewness snaking around a little bit from the diagonal line. And we can look at the test for normality. Oh, here. Okay. So guys, so for significance, we're looking at 0.05 or less, and you can kind of go through the scores and see a few items here that would show significance, significant values. But as you know, we're not surprised by this. First, by the large sample sizes, and then we can see some of the distribution of those hygiene scores being below it or smaller than 0.05, just because of over time we know they got smellier over the days of a concert, and we saw a lot of that skewness and kurtosis in the histograms from earlier. So the data really isn't a surprise. but this does allow us to compare the differences between females and males. And we can definitely show that hygiene scores were more normal for the males when the values were greater than 0.05 than for females, particularly on day 1.